So we're live. So let's talk about Honors Algebra 2 and where we are headed. Okay. So we have a normal full week this week. So today we are going to do section 7-4 day 1. We will do 7-4 day 2 tomorrow. This is adding and subtracting rational expressions. That means fractions. Okay, with polynomials in the numerator and the denominator. That's today and tomorrow. Then we will start solving rational equations on Wednesday and Thursday. That'll be 7-5. Then I back up and do a review over 7-1 to 7-4 because 7-1, 7-2, and 7-3 were all before spring break. We need to refresh that. And then I throw 7-4 in there because you guys kind of struggle with 7-4 a little bit. Okay, that's Friday. Monday, we will review chapter 7 and we will have our practice test for homework Monday night. And then on Tuesday, you guys will go over the practice test. I'm sorry, I need to back up a minute. Tuesday and Wednesday next week is the ELA test, which is the only, that you guys have all kinds of them to take in sophomore year. You have them except for math. The only one you don't have to take is math. So you guys will have your ELA test. If you're a junior, you should be done unless you have government. Am I correct? Okay. So my sophomores, you guys have your ELA testing Tuesday and Wednesday. So we'll go over the practice test one of those 2 days. I only see you one of those 2 days. And then we will take our test over chapter 7 next Thursday. So those of you who kind of want to know where you're headed, your test is next Thursday. Okay, and then we start trig, which is like that always kind of signifies the end of the year is coming to me, and I love teaching it. So we will head into trig after that. Questions on where we're headed? Okay, I did get your test quizzes graded. They were in the computer. I sent out a parent square. When did I can't remember when I did that. Was that Saturday? No. Friday night, Saturday morning? I don't know. I sent out a student square, didn't I?
Oh, yeah. Saturday.
I got it Saturday. Is that when I did it? Okay. So that's where we are headed. If we have time, Drew, I'm going to pass back your test today. Have you guys started games yet or not until tomorrow? And you guys have had some good wins already. 4-1. How about JB? Where are you guys at? What's your record so far? Okay. Good luck. Okay, so let's get focused. Okay. All right. What do you have to have in order to add or subtract fractions? Common denominator. So remember, if I add 2/3 plus 5/3, what do you get? Yeah, you add your numerators, put it over the common denominator. Same thing with subtraction. If I have 2/3 minus 4/3, what do you get? Negative 2/3, and that is correct. Okay, any questions at all on adding and subtracting common denominators? So, first ones. Number 1, do I have common denominators, Chloe? Yep. So you just add your numerators. What do you get when you add 7 plus 3? And what is your common denominator? Now, anytime you have a variable in the denominator, we have to be careful because what is my denominator never allowed to be?
0.
So what would make this denominator 0?
0.
If x was 0. So we have to say, and x is not allowed to be 0. You have to state what x is not allowed to be. Okay? All right, how about the next one then? So, AJ, how about this one? Do I have common denominators?
Yep.
So what do you do to your numerators?
Subtract.
Okay, so can you subtract 2x and 5? So you just write 2x minus 5, put it over your common denominator of Now, you always have to ask yourself, and I hope that you thought this after you added and subtracted these, can I what? Simplify. Can I reduce them at all? Well, remember, to reduce fractions of this form, you have to cancel common factors. You cannot just cancel the x's. They have to be multiplied. There's no GCF that I can take out of the numerator. There's nothing I can cancel common factors in numerator and denominator, so I'm done. But because I have a rational expression, what is x not allowed to be? Negative 6. Perfect. Okay. So obviously we started out with some simple ones where my denominators were the same. Finding the common denominators can be tricky with rational expressions. Okay, with rational expressions. So for example, if I had 2/5 plus 3/5, 2/5 plus 3/5, not 3/5, 2/3 plus, 2/3 plus 3/5. Okay, what's my common denominator?
15.
Is it 15? Okay, so do you remember when you were in elementary school, you would probably say, I'd have to multiply this one by, and you'd have to multiply this one by, and you'd have to multiply this one by, and this one by 3. So what do you get in your numerator? 10 over 15 plus 9 over 15. So what's your answer? 19 over 15. Now, notice your common denominators have the same factors. 3 times 5, 3 times 5. They have the same factors. Okay, that's really, really important. All right. So one of the things you do here, let's take a look at this. Find the least common multiple. Guys, the least common multiple is your common denominator. Okay, what is your common denominator? So if these were the denominators of two fractions, what's the common denominator? Or what is the least common multiple? So what you need to do is you need to factor these. You need to factor these. So Quinn, first rule of factoring is what? GCF. Pull out a 4. And when you pull out a 4, what do you have left? Can that go any further? That's an ugly square. Is this a difference of 2 squares? X2 minus 2. So you have 4x plus 2, x minus 2. Are you good with that? Now, how about this one? What are you going to do over here? Pull out a 6. When you do, what do you have left?
X squared minus 4x plus 4.
Now you have a trinomial, and now a is 1. So what multiplies to give you?
4.
That adds to give you?
-4.
And what is it?
-2.
Okay, is everybody okay with the factored forms of these? Now, technically, I could factor 4 into 2 times 2. And I could factor 6 into 2 times 3. But my guess is, if I gave you 2 fractions and told you the denominators were 4 and 6, what is the least common denominator? 12. Do you guys see that? Do you see that? The least common multiple is 12. Now, if you are struggling with seeing that that is 12, write the prime factorization of 4. That means 2 times 2 times x plus 2 times x minus 2. Write the prime factorization of 6. 2 times 3 times x minus 2 times x minus 2. Now, you have to have everything in common. So what's in common? One of the 2's and anything left over. 2 times 3. Do you guys see that? So what do I have for my least common multiple? I have a 2 in common and then a 2 and a 3 left over. What's 2 times 2? 4 times 3. 12. Now, I know like it's so hard to go through that because that's like so long ago that you guys are to the point now in your lives that I give you a denominator of 4 and 6 and say find the common multiple and you tell me it's 12. You just do it. Okay? But the way you did it back in the day, you wrote out the prime factorization, 2 times 2, 2 times 3. Write what's in common. Here's what's in common. And then what's left over? You had a 2 left over and a 3 left over. That's how you got the 12. Because now we got to do that with our factors. Because watch. What factors in common? I have a what in common? X minus 2. That's in common. And now what's left over that I still got to write? X plus 2 and X minus 2. And this would be your common denominator. Okay? All right, let's try this again. Sometimes I think it's hard when we do these, when I just give you 2 and say find the common denominator. I think this is harder than when I give you an actual problem. So let's try it again. All right, let's help me with the factoring. The factoring should be okay. Karina, just help me with the factoring. What are you going to pull out of B? What's your GCF? Six. Just 6. And when you pull out a 6, what's left? Okay, and then what can you do with x squared minus 9? X minus 3, x plus 3. Now, if you needed to write the prime factorization of 6, you could write 2 times 3. Now, let's do the next one. What can you take out of 9x squared minus 54x plus 81? A 9. When you take out a 9, what's left? What does that factor into? Yeah, because what multiplies to give you positive 9, adds to give you negative 6, it's negative 3 and negative 3. So is everybody okay with just the prime factorization? Now, for the numbers, think about it. If I had a denominator of 6 and a denominator of 9, what number would you guys turn those into? 18s. So I have an 18. Again, you could think of that by doing 2 times 3 and 3 times 3. And then you would say, okay, I have a 3 in common, and then I have a 2 and a 3 left over. So I have a 3 in common, and then a 2 and a 3. So that's 6 times 3, which is 18. What else do I have in common? Start with what's in common. What's in common? And then what's left over? X plus 3, x minus 3. It does not matter what order you have your factors in. Okay, are you guys good? All right. So now we're going to go with find the sum. Find the sum. So what do I have to have? Okay, what do I have to have in order to add? Don't go ahead of me on number 2 or B because I think I already changed it, but let me just don't go ahead of me. All right. On A, what do you have to have? Common denominator. So factor your denominators. I cannot stress how important it is to factor your denominators. Okay? So can you do anything to 9x squared? No, I got 9x squared. But what can I do to the denominator here? What can you factor? What's your GCF that you can take out? When you take out a 3x, what is left? X plus 1. Okay. So What is the least common multiple? Guys, I go to the numbers first. If you had a fraction with a denominator of 9 and a denominator of 3, what would your common denominator be? Are you writing this down?
9. Yeah.
Okay. 9. Now, watch. Remember, you have to have everything. What's in common and what's left over. So be careful. Remember, this would be 3 times 3 times x times x. This is 3 times x plus 1. So what was in common? 3 and the x. And then what's left over? 3 and x. So what do I need? I need 9x what? Squared, because you had the 3 that was in common, the x that was in common, the 3 left over, and the x left over. So that's 9x squared. What else do you have left over that you got to bring over? X plus 1. You got to bring this over. X plus 1. Are we good so far? Now, remember when we added unlike denominators. I said this one was missing a 5, this one was missing a 3. We had to make them the same by giving them all the same common denominators. So, I'm going to come back to this and I'm going to rewrite it with some space. 9x squared. What is this one missing? Well, it needs a what? X plus 1. So I'm going to give it an x plus 1. But whatever I give to the denominator, I have to give to the what? Numerator. Plus, now this one I had x, and I had 3x times x plus 1. What is this one missing to look like 9x squared times x plus 1? Well, I got the x plus 1, but the 3x has to say 9x squared. So what's it missing? A 3 and a x. Whatever you give to the bottom, you got to give to the top. So let's do this one first. Distribute. What do you guys get? 7x plus. Now, on the bottom, do you have 9x squared times x plus 1? Just leave it. On the top, what do you get? 3x squared. On the bottom, what's 3x times 3x? 9x squared times. Do you have common denominators? Can you add your numerators? Now, when I add my numerators, I'm just going to add 7x plus 7 plus 3x squared, but I'm going to put that in standard form. So what would standard form be? 3x squared plus all over my common denominator of Now we have to stop always when we're done. After we added, we say, can we simplify? Can we reduce? So I'm going to look at this. Okay. I'm going to look at 3x squared plus 7x plus 7. Remember, that would have to factor for it to reduce. So I'm going to multiply 3 times 7. What's 3 times 7? Does anything multiply to give you 21 that adds to give you 7? I got 1 and 21. 2 is it 3 and 7. Do any of those add to give you 7? So does that trinomial factor? Nope, so it's not going to reduce because nothing cancels. Now, what is x not allowed to be? 0 and crazy fun stuff. Okay. Let me see if I... Please change this problem. This problem needs to be changed to 3x squared. Is it changed on yours? No? Can you guys change that for me? Okay. Let's go. Let's factor the denominators. Jack, can you do anything, Jack, to factor the first one? No. Okay. What can you do over here to factor this one? Factor out a what? I'm actually going to do this off to the side because when you factor out a 3, what's left?
X squared minus 4.
And then what does that factor into?
3x plus 2x.
Yeah, it doesn't matter which one you put first. You're right. Okay. All right. Whew. See if you guys can find the denominator. Common denominator. Already lost. That's algebra 1.
Oh, shoot.
Jack, do you have the common denominator? Okay, what's the number you need? What number's in common? 3. You got a 3 in common. Nothing else is in common. What's left over? X squared. What else? X plus 2, X minus 2. Okay, you got what was in common and everything else left over. There's your common denominator. All right, so I'm going to rewrite this. And now we're going to figure out, Jack, what we need to give to this one, which is a lot. So what do you need to give to this guy? Okay, X plus 2, X minus 2, X plus 2, X minus 2. Okay? Plus, now over here, let's see, I have a 3, I have X plus 2, I have X minus 2. What is this one missing? X squared. So I'm going to give the bottom X squared. That means I give the top X squared. Are you good so far? Okay, I am going to work on adding, because what do I have to do now? I have to clean all this up. I'm gonna put all this together. I'm gonna put all this together, and then I'm gonna do what? Add them. And I don't want to keep rewriting that denominator, so I'm gonna work with just my numerators right now. All right. So Jack, the 1 kind of goes away. Are you done? Just set that all on my desk, and can you just hang out there for this rest of the period? All right. What do you get when you FOIL here? X squared.
X squared, X plus.
X squared minus 2x. 2x. So those go away. And then what's left? Minus 4. Okay. So that's that part. Plus, what do you have over here? X to the 3rd. Okay, are we good? Now rewrite this in standard form, Jack. What do you get for your numerator? All over your common denominator, which was
3x squared.
perfect. Now, guys, we always got to say, can I reduce this? Well, look at your numerator once. Guys, that is a trinomial, but does it go in any factorable form? Like if it went 4 to constant, we could factor it. But if it goes 3 to constant, can you factor it? No. So he's done. What is x, everybody, not allowed? What is x not allowed to be? 0, negative 2, and 2. Perfect. I know.
Terrible.
It's not terrible. It's fun stuff.
No, it's just long.
It is long. All right. Alright, the difference is very similar to the sum. The only thing is we have a minus sign between these. And we just have to be a little bit careful when we're working with them. Okay, Justin. Everybody's like, alright, Justin, help me factor this. No, don't tell me you don't know. Help me factor. What are you going to factor out of the denominator?
2.
Stop. What do you have left?
X minus 1.
Okay, what are you going to do here? Trinomial minus 1, like it's easy. What multiplies to give me?
3x gives you negative 4. Negative 3, negative 1.
Negative 3 and negative 1. Okay, so everybody take a second, find your least common multiple. All right, you should be done. Justin, what's the same in both of them?
X minus 1.
X minus 1. You need one of those. What else is left over that you haven't used?
2.
And
X minus 3.
there's your common multiple. All right. So I'm going to put x plus 2 over 2 times x minus 1. What's this one missing, Justin?
The x minus 3.
X minus 3. So give the bottom an x minus 3. Whatever you give to the bottom, you got to give to the top. Now be careful. We have a minus sign here. Denominator, I had x minus 3. I had x minus 1. I had negative 2x minus 1. What is this one missing? The 2. So I'm going to give a 2 here and a 2 here. Now, this is where the numerator gets a little algebra heavy. It's not hard. You just have to slow down and think. Okay, I'm going to work on the numerator only because you have this with a minus between them. So, Justin, help me over here. What do you get when you FOIL this?
X squared.
Uh-huh. Then what?
Plus. No, is it minus x?
Uh-huh.
And then minus 5. Or no, minus 6.
6. Okay, and then what do you have in between them?
Minus 5.
And then when you distribute this, what do you get? But remember, it's minus this quantity. So it's minus what? When you get when you distribute 2.
Negative 4x minus 2.
And now what do you have to do with this negative?
Distribute that into.
Yeah. Now some of you might have just distributed a negative 2 and that works as well. And what do you get here?
Plus 4x plus 2.
And now clean up that numerator. Again, I'm only working with the numerator. Let's see. We have x squared plus what?
Oh, sorry. Plus. Would be plus 3x and then minus 4.
Good. And this is all over my denominator. Whew, okay. Is everybody okay so far? What do I always have to check? If it what? How do we simplify rational expressions? By factoring. So now you ask yourself, okay, this is a trinomial, a is 1, life is easy. Is there anything that multiplies to give me negative 4 that adds to give me 3?
4 negative.
Positive 4 and what? Uh-oh, so did that numerator factor? What did it factor into? X plus 4, x minus 1 over 2 times x minus 1, x minus 3. Holy cow, right? Now is something going to reduce. But before I reduce, what is x not allowed to be?
1 and 3.
1 or 3. What reduces?
The negative 1.
X minus 1's What do you have left in the numerator? X plus 4. What do you have left in the denominator? 2 times x minus 3. That is a fantastic problem. All right. Do it. Welcome back. Mitchell, how do I factor this denominator? What question do you ask yourself?
Multiplies to give you 2, and adds to give you
Multiplies to give you 2, adds to give you negative 3.
Hang on.
Don't overthink it. What's the only thing that
3 and 1. Negative 3 and 1.
that doesn't, I'm not multiply to give you 2. What's the only thing that multiplies to give you 2?
2 and 1.
Okay, but they have to be what?
Negative.
What are you going to factor out of the denominator over here?
2.
What do you have left?
X minus 4.
What on earth happened there? Okay, you have a 2 and you're left with x minus 2. Okay, common denominator. Okay, what's in common?
2. Or x minus 1. Or x minus 2.
The x minus 2 is in common. What's left over that you have to have with it?
2.
And?
X minus 1.
Alright. So, I have the 5x minus 1 over, I started with x minus 2, x minus 1. What is this one missing, everybody? 2. Whatever you give to the bottom, you got to give to the top. Minus, I had negative 2x minus 1. I had 2 times x minus 2. What is this one missing? X minus 1. Now remember, you have this minus this. Yes, sir.
Why do you need the x minus 2 in the least common multiple if they both already have it?
Well, I didn't give any of them an x minus 2, but it's part of your common multiple. Remember, you go, what do you have in common? An x minus 2 plus anything that's left over. All right, so now distribute here, everybody. What do we get? I'm going to work with just my numerator. 10x minus 2 minus, now leave this in parentheses because it's minus this whole FOIL. Okay, what do you guys get when you distribute here? You get negative 2x squared, and then I get positive 2x minus 1x, so I get what? Plus 1x, and then 1. Now distribute this negative. Give the negative to everything. 10x minus 2 plus 2x squared minus x minus 1. So this, I don't think this is hard. It's algebra heavy. So I have 2x squared plus what? 9x minus 3. All over my common denominator. God bless you. Okay? And you would try to factor this. It doesn't factor. You should try though. What does x not allowed to be? 2 more. It is long. 1 through 21 odd. Fun stuff.